lesson, we're going to go back over, this is just review, so don't get excited, the co-function identities. Well, I never asked you to memorize them, and you don't have to memorize them now. I asked you to memorize a statement that said, co-functions are equal when what? When their angles, come on guys, when their angles what?
Are complementary.
Are complementary. That means that they add up to 90. Now that's in degree mode. If you're in radian mode, what would they need to add to?
100 and, no.
What's the equivalent of 90 degrees in radians?
2 pi.
What?
2.
What? Pi over 2, yeah. So
It's written right there.
co-functions, yeah. Co-functions are equal when their angles are complementary. In other words, they add to 90 degrees or pi over 2 depending on which mode you're in. So really, that's all these are saying, if you think about it. You know, if this angle right here, if theta is 40, then this one has to be 50. If theta is 20, this has to be 70. So do you understand that? Yes? Do you remember that?
Yes.
Sort of. Your book loves these. They just pop back up every couple of chapters. Okay, so for this example, we want to find one value of theta or x that satisfies each of the following. We know that cotangent of theta equals tangent of 25 degrees. A lot of you missed this the last time I put it on a test. You just set theta equal to 25, but that's not true. What do you have to do? You have to take theta and add it to 25 and set it equal to 90, right? So that means that theta equals 65 degrees. Now, notice that it says one value. There actually are how many values? Infinitely many, because if 65 works, then whatever 360 plus 65 is would also work. And you could keep adding 360, and that would give you a new answer every time. So we'll only ask you to find one. How about the second one? What does this have to be if this is negative 30?
60.
So would 60 work? 60 plus negative 30, would that go to 90?
No.
What would work?
Negative 60.
120 would work, yeah. So let's see how we could like prove that. We say theta plus negative 30 degrees equals 90. And so really, instead of subtracting 30, I would add 30 to solve that equation. So we have theta equals 120 degrees. Those are really easy, right?
Yes.
Okay. Please don't miss them again. I think that's part of why the book throws them back at you every so often, is you just forget those. It's like you look at it and you just lose your mind. But if you see a cotangent equal to a tangent, a sine equal to a cosine, or a secant equal to a cosecant, it must be true that their angles are complementary or that it's a coterminal to a complementary. But the only ones we'll ever ask you to find are the actual complementary ones. Make sense? Okay, so for this one, we are given the cosecant of 3 pi over 4 equals the secant of x. Because it's in radians, we don't want to add them up and set them equal to 90. We want to set them equal to pi over 2. So we will take 3 pi over 4 plus x and set it equal to pi over 2. Subtract 3 pi over 4. We have pi over 2 minus 3 pi over 4. And hopefully by now you guys could do that without a calculator. You're finally learning how to add and subtract.
Could you convert it to,
Could you convert it to degrees?
You could, but then you would have to take that answer and convert it back to radians. Because you have to give the answer the way it was the original was given to you. But that certainly would work if you didn't want to add and subtract. But to me, it's harder to convert than to just go ahead and subtract them. So what is 1/2 minus 3/4? That would be 2 pi over 4 minus 3 pi over 4 is negative pi over 4. Great. So that would be one of the angles that would work. How could I find another one that would work? Instead of adding 360, what do we add to radians? What's a whole revolution of the unit circle? 2 pi, yeah. So if you wanted to find some others, you could add or subtract 2 pi from it.
Will you ever ask for more than one?
No, but I just want to make sure we remember that that is how we find coterminals with radians. Okay. Let's see what's next.
Yeah, I love these slides.
Oh, look, note, because trigonometric functions are periodic, the solutions in example 2 are not unique. We give only one of infinitely many possibilities. But we talked about that as we went. That's what you would use the coterminals to find the others. And that brings us, to another slide that doesn't have a problem on it. This is great. Applying the sum and difference identity. Now the problems get a little different after this, so if you're going to have any trouble, it's going to be with the last few. Here it points out that if either angle A or B in the identities for cosine A plus B and cosine A minus B is a quadrantal, then the identity will allow us to write the expression in terms of a single function of A or B.
So like cosine of A minus sine of B or something.
Well, it'll depend on what the other angle is. I guess what they're saying is if it's a quadrantal, either sine or cosine is always 0, right? So one of those terms, either the cosine or the sine is going to collapse to 0. So you can show some really neat connections through this. Let's take a look at this one. If I want to write the cosine of 180 degrees minus theta as a trig function of theta alone, basically we just take that expression, we expand it out using the identity, and then we just sort of plug in what we can. So the cosine of 180 minus theta. How will that expand? It'll equal the cosine of 180
negative,
times the cosine of
negative,
theta, right? Plus or minus? Plus the sine of 180 times the sine of theta. And so obviously we don't know what the cosine and sine of theta are, but we do know what the cosine and sine of 180 are. The cosine is, think about it, -1, because it's the coordinate pair -1 comma 0. But the cosine is 0. No. The cosine of theta just stays cosine of theta. Oh, indeed. The sine of 180 is 0. And then according to the order of operations, you have to multiply before you can add and subtract. So this first term will just become negative cosine of theta, but the whole second term becomes 0, regardless of what the sine of theta is. So see how it went from looking like a whole lot of functions down to here? So this means that the cosine of 180 minus theta is actually exactly the same as the negative cosine of theta. I don't know when that would be useful, but hey, now we know how to do it. You have a question?
Yeah, I thought cosine was like, if it was multiplied by a negative, it was still positive, you know?
That's if the angle is multiplied by a negative.
Oh.
You know, like, if cosine of negative theta does equal cosine of positive theta.
Oh, okay.
Right, that's if the negative is inside here.
Okay.
So if it's outside, you still leave it negative there.
Alright.
Okay.
Well, on the 2 problems ago, it was like sine of theta equals cosine of negative 30 degrees.
Mm-hmm.
How would that work?
That's 2 separate things,
Alright.
because that's dealing with the cofunctions. That's a sine and a cosine equal to each other.
Okay.
You know, so that's just a whole different scenario. It's kind of weird. This is just a weird collection of problems of things you could do with it. They're not terribly useful, but they do help build some logic skills, allegedly.